Alright, so hopefully this is our last video for 2-4, the chain rule. Now today we're going to focus on, in fact in this video, not today, we're focusing on trig functions and the chain rule. So, if we have the function y equals sine of u, all that means is y prime is going to equal cosine of u times u prime. If we have the function y equals cosine u, our derivative y prime is going to equal negative sine u times u prime. If we have the function y equals tangent u, our derivative is going to equal secant squared. In fact, I'm going to write this with my pen. Secant squared u times u prime. I'm just going to keep going with my pen on these. If we have y equals cosecant u, then y prime is going to be negative cosecant u cotangent u times u prime. If y is equal to secant u, then y prime is going to be secant u tangent u times u prime. And finally, if we have y equals cotangent u, then the derivative is going to be negative cosecant squared u times u prime. So let's look at some examples. So example 8, we're going to have a few parts here. We're going to have 8a, where we will have y is equal to cosine x minus 1. So, when we're finding the derivative of this, y prime is going to equal, derivative of cosine is negative sine of x minus 1 times, we're going to take what's in the parentheses and call that u. So the derivative of x minus 1 is just 1, which means this derivative is just going to be negative sine of x minus 1. We're going to look at one more. We're going to have y is equal to the tangent of 3x. So y prime, well, derivative of tangent is going to be secant squared 3x times the derivative of 3x, which is 3. So we can rewrite this as 3 secant squared 3x. Now we can't go 3 times 3 because that 3x, we need to find the secant squared of it before we can multiply anything by 3. Let's look at another example. We'll call this next one example 9. And our first one, we're going to have y equals cosine of 3x squared. So we're going to write y prime as, well, derivative of cosine is negative sine 3x squared. And then we take the derivative of the 3x squared and we multiply that sine part by it. So 3x squared's derivative is going to be 6x. If we multiply, we're going to end up with a negative 6x sine of 3x squared. Let's look at another one. Y equals cosine 3 times x squared. Well, cosine 3, that has no variables in it, so that's actually just a constant, which means when we're finding the derivative of this function, we're really just finding the derivative of x squared. And then we multiply it by cosine 3. So the derivative of x squared is 2x, and then we multiply cosine 3. So we've finished that derivative. I think we can fit c on here. C is going to be y equals cosine of 3x squared, which is the same thing as cosine of 9x squared. So we want to find the derivative of that. Y prime is going to equal derivative of cosine is negative sine of 9x squared, and then we multiply that trig part by the derivative of 9x squared, which is going to be 18x. So our final answer is going to be negative 18x times the sine of 9x squared. Let's look at a couple more. So we've got example 9D. We're going to have y equals cosine squared x, which we can also just call cosine x squared. So when we're finding y prime, we're going to start by bringing down the 2 times cosine x, and then we multiply that by the derivative of cosine x, so negative sine x. If we're writing our final answer, let's multiply. We're going to get a negative 2 cosine x times sine x. And that one is completed. Okay, let's look at one more. We're going to have y equals the square root of cosine x, which we know the square root, we can rewrite that as cosine x to the 1/2. So y prime, we're going to bring the 1/2 down, and then we have to multiply it. Oh, I forgot, I need to also put that cosine to the negative 1/2. Then we multiply by the derivative of what is in the parentheses. So negative sine x is the derivative of cosine x. Let's bring our negative exponent down. So in our numerator, we're going to be left with a negative sine x. Our denominator is going to have 2. Let's just rewrite the power of 1/2 as square root cosine x. Alright, let's move on to our last two examples. We're going to look at example 10, and then we'll look at example 11 when this is done. So 10 is going to be f of t is equal to sine cubed of 4t we can rewrite this, as sine of 4t cubed. So when we are looking to find the derivative f prime of t, we can bring the 3 down, rewrite sine of 4t, and then square that. Then we have to find the derivative of sine of 4t, which is going to give us cosine of 4t. But we're not done. We still have to find the derivative of the 4t part, which is just going to give us a 4. So we can simplify all of this. We can multiply 4 and 3. We can get 12 sine squared 4t cosine 4t. And we are done with that one. So let's look at example 11, where we are going to find an equation of the tangent line to the graph of f of x is equal to, I want all of this on the same line, 2 sine x plus cosine 2x at the point pi, which you can just write the symbol for pi. I don't have that on this keyboard. Pi 1. Then determine all values of x in the interval from 0 to 2 pi, at which the graph of f has a horizontal tangent. So the first thing we're going to do is find the derivative of the function. So let's find f prime. So f prime is going to equal, we've got an addition rule here, so we'll find the derivative of the first term and of the second term. We're going to have the derivative of 2 sine x is going to be 2 cosine x plus the derivative of our second term. We're going to have negative sine x is the derivative of cosine. So negative sine of 2x times 2, because we have to use the chain rule there. So our derivative is going to end up being 2 cosine x minus 2 sine 2x. So there's our derivative. For part 2, we're going to find f prime at pi. So let's put in pi for x. We've got 2 cosine of pi minus 2 sine of 2 pi. Well, cosine of pi is 0, so we've got 2 times 0, minus sine of 2 pi is 1, so 2 times 1. So we've got 0 minus 2, which is negative 2, which we're going to utilize that in our third part to write this equation. We're going to use negative 2 as m and pi 1, and we're going to use point slope form. Y minus y1 equals m times x minus x1. So we're going to have y minus 1 equals negative 2 times x minus pi, which we can distribute the negative 2. We'll get y minus 1 equals negative 2x plus 2 pi. Then if we add 1, we'll get our tangent line to be y equals negative 2x plus 1 plus 2 pi, which that was one of the things they asked us to do. Write the equation of our tangent line. Now we're going to find out where the graph has a horizontal tangent. So I'm going to use a new page for that. You can keep writing. Now, a horizontal tangent means that the slope is 0. So we're going to take our derivative and set it equal to 0. 0 is equal to 2 cosine x minus 2 sine of 2x, and we're going to solve this for x. Now, both terms on the right side of our equation have a 2, so we can just rewrite this as 0 equals cosine x minus sine 2x. And utilizing our double angle formulas, we can rewrite the sine of 2x. So we'll have 0 equals cosine x minus 2 times sine x cosine x. Now, I do notice that both terms also have a cosine, so I'm going to factor that out. I have 0 equals cosine x times 1 minus 2 sine x. Now, I'm going to set each of these equal to 0, so cosine x equals 0, and 1 minus 2 sine x equals 0, and I'm going to solve them. Well, cosine x equals 0, already done. If we use our unit circle, we'll find that x could be all the values where cosine is 0. X can be either pi over 2 or 3 pi over 2 if we're looking in the interval from 0 to 2 pi. If we're solving the second equation, we can have 2 sine x equals 1. So the sine of x equals 1/2. Well, when sine is 1/2, that means x, it has to be pi over 6, or it can be 5 pi over 6 using our unit circle. So that means x at the points pi over 2, 3 pi over 2, pi over 6, and 5 pi over 6, we're going to have a horizontal tangent line, and that's going to wrap up our lessons on the chain rule.